So, hi, today I'm going to discuss the next question in the Leetcode Top Interview 150 study plan, that is insert, delete, get random of 1. So, what this question basically asks is to implement a random by set class which does the following operations, that is inserting element, returning if it is already present or not. For example, if the item was not present, return true, false otherwise. Similarly, for remove function, removes an element from the if present, returns true, if false otherwise. And get random allows us to select a random element from the array with equal probability such that if for example 1 2 3 4 5 6 are currently present in the array, so each of them has an equal probability of being selected. So to do this question, the simplest approach is to store the elements. So the simplest approach is basically storing an array, iterating whenever I need to, like ending an element to the end of the array or the linked list, then removing by iterating all the array. For a linked list, I'll break like connection and make it to the correct next. But for an array, I'll have to erase the element and resize the array completely. But it would not satisfy the criteria of this question, that is giving a O of one solution. So what I will do here is I'll try to uh, use a different solution using an array and a map. So let's first define an array vector int, let's say ls for list, and let's define an unordered map, say with type int comma int, and let's name it mp. I'm leaving the initializing uh, thing as it is. For the insert, if mp dot end is not equal to mp dot end, that means the element already exists in the array. So we need to return false for this case. And if the element was not already in the array, I need to insert it and return a true. So to do that, I'll do mp uh, mp dot val, that is my current value. I'm storing at what index, so I'm basically pushing it at the end of the array list. So I'm going to take the size of the list, the current size of the list, and insert it at the end. So I'll do ls dot size. At the same time, what I need to do is insert at the end of the list so that the list also contains the element. I'm using the map simply for a O of one axis so that I know key at what index inside the list I'm actually storing the element. So I'm going to do push underscore back val, and as I have pushed a new element, I need to return a true. The get random is also very simple to code. To do that, I'll first get a random index using rand function and divide and take a mod with the size of the list, so that for example there are 7 elements in the array. We get a number at random, like for say 100. and we modded it with 7. So we have in each of the time while modding, it will be get divided, any number will get divided into 7 buckets. That is 7 possible outcomes of the solution. So it will always give a random output. So I can do return ls.index, that is current random indexes element. So remove is a bit tricky. So because we need it to be actually in O of 1 and not take up any extra space also. And so what we need to do is firstly, if mp dot end, uh, sorry, not mp dot end, mp dot find value, that is our value we have to remove. If it is not already in the array, so we that way we can't actually remove it. So we need to return a false in this case. Otherwise, what we do here is int index um, of the current value. So how do we get an index? We stored it in the unordered map. So I'll do mp dot val. Once I have the index of the element, what I will do is replace it with the last element. So why I'm doing replacing with the last element? Because when I replace it with the last element in the list, I could reduce the size of the list while keeping the number of elements that I want in a lesser size without like extending the list or like reiterating and recalculating the new list. So what I'll do is mp dot ls dot back, the last element in the array. I'll name it as the current index. That is current index that I'm removing from the array. So I'll name it that, and I'll do mp dot erase that element from my basically map. So as I've done this, now I have to do similar thing with the list so that the list also don't have the using the extra space and have successfully replaced the last element with the element I have actually removed. So to do that, I'll do ls dot index is equals to ls dot back. So what it does, it will replace my current index that I am removing with the current last element, and then I'll do ls dot pop back. What this will do is it will remove the last element from my array so that we are back to, like, for example, I have 8 elements and I remove third element. So it will firstly replace the third element with the last element, that is the eighth element, and then reduce the size by 1. That is new size becomes 7. So I return true. Let's see if it is working fine. So I'm getting an error. Okay. So okay, I did an error here. I need to instead use find instead of mp.end because it will always return false. So I don't want that. I need to actually search for the value inside the map to return true or false. To check if the value is present, then I don't need to reinsert it again. So I'll return a false. Otherwise, if I can insert it, it's a new value, I'll return a true. So now let's check if it is working fine now. Okay, it is working fine. Okay, yeah. So it is giving a decent answer. So okay, so why is this solution actually O of one? So because we are using unordered map and list, we simply know the index at which the element actually occurs. So we could straight away get a value, and that's why the solution was O of one time complexity. Because every new element we try to access, we could simply check from the unordered map, get its index, and we can simply insert, remove, or get a random. And as for the space complexity, we are actually using unordered map and vector. So the number of element that is n will both of them will actually have. So the space complexity of O of n will be there. So yeah, that's it. Thank you.